Well, Bhava Atomic Research Center has released its advertisement about the recruitment of scientist position. Now, do you know that cracking the interview of BARC is an achievement by itself? And why is that so? The reason is that by far, BARC interview, if I at least talk about mechanical engineering, is the toughest interview throughout the country. And this is not as per any documented information. This is as per the interview candidates' experiences. Now, if you have cracked BRC interview, then you have done something. Having said that, hands up, I have not cracked BARC interview. I appeared for that, but I was failed. Okay, so I failed to crack BARC interview. Now, at this point, if someone from you is thinking that okay, he has not cracked BARC interview, he failed to crack that, I will not see this video, then it is perfectly fine. I can understand that. But let me tell you, my failure was not solely because of my lack of knowledge. It was because of something else. And that is very much important to know. To learn from that is very much important because you should know. And I hope that already you have appeared for some interviews, and by this point, you know that interview is not only about your knowledge, it's about your attitude, it's about your confidence, it's about your style of speaking, and all these things. So, although BARC solely conducts an academic interview, they will not ask any type of HR questions, but people fail to understand, consequently, that I need to develop something else. Okay. I mean, not studying is only enough for this kind of interview. Okay. Study, I mean, people think that, okay, I need to just solve questions. No, they also see something else. And what are those something else? About this, I will talk in this video. Specifically, I will share my failure story. See, I have cracked GATE with AIR 31, AIR 94. I have cracked ISRO and DRDO. I am the topper in IIT. But still, I have also failures. I failed to crack JE. So, why only to share the success stories and not the failure stories? So, this is one of my failure stories. And you can learn a lot from this thing. Okay. Now, see, if you are appearing for GATE, you need to understand its syllabus, its question pattern. Similarly, if you want to appear for BARC, you need to understand the interview environment. So, is it very much easy and cooperative, or is it very much harsh? So, you need to know all these things, that what you can expect. Based on that, you need to build your mentality before the interview. So, don't worry. In the next video, I will show up with a clear strategy to prepare for the BARC examination, and more importantly for the BARC interview. I will talk about the sources from where I have prepared. But in this video, I will firstly talk about the BARC advertisement, because I know that many of you do not know about what is BARC OCES program, and also what is BARC DGFS program. So I will talk about that. After that, I will share with you my full interview experience along with the specific questions that I was asked. Okay. So I think this will be a very interesting story, and stay tuned. So here I have the advertisement. Okay. And here, firstly, I will talk about the two programs. So here we can see there are two programs, OCES and DGFS. Okay. So first of all, you can see that I mean, here it is already there that you have to appear for, if you appear for OCES, then it is a 1 year orientation course for engineering graduates and science postgraduates. Okay. This thing I am just saying. Okay. So this will be like, it will be given and 1 year training. It will be a course. Okay. I mean, it will be taught something, and based on your performance in the examinations. Okay, you you will be given choices. For example, if there are 25 candidates, and for them there will be 25 job roles at 25 job sites. If you have appeared first, okay, if you have ranked first in the examination, then you have all the 25 choices. Okay, these kind of things will happen. Okay, okay. So see, they have already stated that on successful completion of the OCES program, trainee scientific officers will be appointed as scientific officers in one of the DAE units or atomic energy board. Okay, and next we have the DGFS. Now DGFS, they will sponsor you for M.Tech, but here is a catch that I will show you. Okay, or let me show you. See, here there is something called the DGFS Institute. If you think that I want to study in IISc, so will BARC sponsor me? No, they will not sponsor you. Only IIT Bombay and IIT Madras are here for the DGFS Institute thing. Okay, IISc Bangalore is not there. And for specifically mechanical engineering, if you see that for thermal and fluids engineering, thermal engineering, design engineering, mechanical design, there are two options, IIT B and IIT M, IIT Bombay and Madras. But if you think that I will join for the applied mechanics, okay, then there is only IIT Madras. So you need to see this document obviously. Okay. So what I will do is I will give the link of this document in the description and also in the pinned comment. Okay. Now, this was the most important thing, that for DGFS, you will be sponsored, okay, for your M.Tech, but only in the DGFS institutes and not in any institute. Okay. Here it is mentioned that on successful completion of the DGFS program, placement for DGFS fellows will be either at BARC or at IGCAR. So this is also an organization under the DAE, Department of Atomic Energy. Okay, so you can search for the full form of IGCAR. It is something like Indira Gandhi's. Okay, so here the main difference is that in this 1 year orientation course also, I think that you will get a certification that you have done an 1 year course and it is like a diploma. And this is mostly like an M.Tech, and actually this is not like an M.Tech. It is an M.Tech degree. Okay. Okay. So this was the main thing. And here it is written that the eligibility criteria. Okay. So you have to know that you have two options. Either you can apply for the examination and you can appear for the examination, or you can apply via your gate score, or you can apply via both. Okay. So yes, obviously people apply via both, and if you can get call from examination, then also you are eligible for the interview. If you can get the call from the gate score, then also you are eligible for the interview. And if you can, you can also get call from both the streams, then also it is okay. Okay, but you have to see that here it is mentioned that if you are appearing for the branch mechanical engineering, then the gate subject should be ME, and also you should have either BE or BTech or BSc engineering or 5 year integrated M.Tech in mechanical engineering. So I often see that people ask that, okay, bhaiya, I am doing my bachelor's in PI, production engineering, or CE, okay, civil engineering, chemical engineering. So am I eligible for BARC? So in this document, you see, so here is nothing called PI. Okay, so see, production engineers are not eligible for this round. Okay, but for mechanical, for chemical and metallurgy and electrical, electronics and computer science, and instrumentation, civil engineering, physics, chemistry, bioscience, geology. Okay. And also the other thing, like how much minimum CGPA or how much minimum percentage of marks should be there to be eligible for this post, that is also, I think, mentioned here. Okay. So that will be mentioned here. Okay. You can go through carefully. Okay. So there it is mentioned. I mean, throughout this document, everything is mentioned. Okay. You don't have to worry about anything. Okay. And also, you see that during, if you join the OCES, then stipend and allowances, OCES, TSOs, and DGFS fellows are paid a stipend of 74,000 per month. So actually, they have increased it. Okay. So see, generally, M.Tech fellows get only 12.4K. I also, received that stipend. But if you join the DGFS program, so you can enroll in either IIT Madras or in IIT Bombay for M.Tech, and you will be getting a stipend of 74,000 rupees per month. But here is a catch. If you feel that after completing the program, I will not join BARC, then you have to return something. Okay. And that is, I think, 10 lakhs. Okay. That will be also here. So that is the bond money. Okay. So because they are paying you 74,000 per month and they are sponsoring your M.Tech, or they are sponsoring your OCES 1 year course, and because of that only they will demand you that you will serve the BARC at least for, I think, the bond time is at least 4 years or 5 years. So you have to take care about that. Okay. Or you can, you can at least leave BRC. Okay. But you have to pay that bond money. Okay. But after the, completion, when you will be appointed as a scientist, then there will be the pay scale. The, basic pay is 56,100, and on that you will get the HRA, TA, DA, all these things. Okay. Okay. So I think this is all about the BRC advertisement, and mostly the interview will be there in the Mumbai. Okay. So there is a place called Anushakti Nagar, and that is the campus for BRC itself. And that is very big and very beautiful. If you can get the chance also, visit that campus just because you are selected for the interview. That is also a very good experience. Okay. So here, BRC Mumbai. Okay, that is the Anushakti Nagar. So see, this is the screening disciplines through which candidates selected. Okay. So if you are from mechanical branch or from civil branch or for CAs, from mechanical, from instrumentation, then your interview will be in Mumbai. If you are from geology, then your interview will be in Hyderabad. Okay. I think everything almost, important things has been covered. Okay, now here, you can take a screenshot also. So, launching of the online application portal is 2nd January. Okay, last date for online application is 26th. Okay, mark it. And correction window. So, this is something new. Okay, I think when I applied, there was no, correction window. So they have given and 1 week correction window. Okay. So that is all. Now let me share with you my interview experience. So my BARC interview experience. So firstly, when you will go into the Anushakti Nagar in BARC, then there will be something called new boys hostel or something like that. Okay. So your hostel or the building where you will be accommodated, that will be just beside the actual interview building. Okay. So you don't have to worry about that. I need to walk a lot from my building to the interview building. No, those things are not there. I mean, and also the food is not cheap, but the food is good, and that is not very much expensive also. Okay, so you can get a good meal like fish, dal, chicken. Okay, within within maybe 120 rupees as far as I can recall. Okay, so other than that, you have to pay an amount of 800 rupees per day. As far as I remember, either it was 800 rupees per day or it was 400 rupees per day. Okay, or per night, I should say. Okay, for the accommodation. So, I should mention that it is far more costly than the DRDO thing. Okay, so in DRDO, accommodation, food, all total, it was almost 300 rupees. And here, just to stay for one night, you have to give 400 rupees. And mostly they will accommodate three persons in a room. Okay. And obviously, it will be a non AC room. And generally, the interviews happen in the month of May and June. So maybe it will be a bit hot there. Okay. So best of luck with that. Now, you will have to obviously reach the place, okay, the hostel building a day before. If you are not from Mumbai or any place, which is near to Mumbai, maybe from Pune. If you are not from any of the places like that, then you have to go to the building, okay, just one day before, okay, because you don't want to have any bad experiences or you don't want to experience any kind of hurry, right? Okay. So now after that, what you have to do is that on the next morning, you have to report the interview hall within 8:30 a.m. Generally, the timings always stay same. Okay. So it will be 8:30 a.m. where you have to, report. So there will be a big hall. Okay. And in that hall, you have to carry your all the documents, both the Xerox copies and the originals. Okay. And they will give you a form. At least, not one form, but there will be two forms. So in one form, you have to do in one form, as far as I can recall, you have to mention the all the the minute details that your percentage in B, your gate score, your branch, whether you are interested for DGFS or not. Okay, so for DGFS and OCES, the same interview will be there. Okay, and I am talking about the interview on. Okay, and not the examination. For the examination, I will make a separate video that how to do the preparation for it. Okay. Now, in the two forms, they will guide you. One person will speak in mic, okay, that you need to write this in that, you need to write that, this, okay. So, now there is an advice from me during this time that try to fill this form as fast as you can if you want the delay. Sorry, if you do not want the delay. Okay, otherwise your interview can take place in the maybe at 6 o'clock, 7 o'clock, because when you will be getting the admit card for the interview, or I should say the call letter for the interview, then in that call letter one sentence will be there that your interview can take place till 9 p.m. also. Okay. So the interview order will be, according to that, how fast can you get your documents verified? If you are the first person who has who has got his documents or her documents verified, then you will get the slip, okay, of the interview, okay, and in that slip your serial number will be there. So if you are the first one who has got his or her documents verified, then maybe you will be the first one for the interview also. Okay. So in that case, I want you to do these things carefully and fast. Okay, as fast as you can. I mean, having said that, don't make any kind of mistakes. Okay, you have to be, I mean, attentive, mindful, and fast while filling the form. And if you are okay with the thing that, okay, I don't care that how much it is. I mean, I am okay with my interview happening at the night also. Then you can take your time as much as you want. I mean, before the document verification. So this was the story before the interview. Okay. And now I will start with the interview hall. Okay. So now the heartbeat will go up. Okay. So it was the actual thing that be it BARC, ISRO, DRDO or any IIT, IISc, I mean, wherever you are appearing for an interview, your heart rate will go up, right? So, and it is BARC interview, we all know. Okay. But try to stay calm. Okay. This is the first advice for any interview. Okay. So when I entered into the interview hall, I was asked that this is the gate score for 2023, right? So the chairman asked. I said, yes, sir. So then he said, so what you were doing for the past year? So this is not an HR question. I mean, honestly, they only do care about your scientific knowledge and actually nothing else. Okay, so I mean, even if they can ask this type of questions, but this will be not, I mean, counted for your interview performance. Then he asked, and I told him that I am doing my master's from IIT Kharagpur in thermal and fluids engineering. He said, okay. Then they told me that this is totally a technical interview and you have to write in short your 4 favorite subjects. So I wrote obviously in the order TD, that means thermodynamics, and FM, that means fluid mechanics, then heat transfer, then SOM. Now here you can see that these three are from the thermal and fluids part, and this is from the design part. So it is often the case that if you choose all of the subjects from the thermal and fluids, then they will ask you to choose at least one subject from design. And similarly, if you choose all the subjects from design, then they will ask you to choose at least one subject from thermal and fluids. So ideally, you should choose 3 subjects from thermal and fluids. Okay, I mean, you should at least take 2 combinations. Okay, you can also take, I mean, like this, that uh, thermodynamics, engineering mechanics, heat transfer, material science. Okay, then maybe theory of machines. You can have this type of combinations also. And moreover, if you give them this type of combinations, then they will be actually happy. You know why? Because most of the students give these type of combinations. Okay, and obviously they get bored, right? And they want something new. And if you can give them something new, then they will be happy. But at the same time, if you cannot perform well, then they will not be happy. Okay. Now let me start with the question. The first question. So here, what the first question was that draw a tank. Okay. So from now, please see the video very carefully, not only the questions. I will be sharing all the comments and the words of the interviewers. So please be very attentive. Okay. Because from this point of the video, you will be actually knowing the mentality of the interviewers. Based on that, you have to grow your mentality. Okay. Now this is a tank. Okay, and they have also, I mean, given that the tank is filled with water. Okay, tank is filled with water and the tank is very large. Okay, now at this point, you need to focus on every word of their questions which they are asking. Okay, because every word can have some meaning. So this very large is having some meaning actually. Okay, so now they are saying that okay, at the below there is a balloon attached with a string, with a string. Okay, like this. A balloon is attached. Okay, with a string, and it is given that the height from the top to the balloon, okay, is h. And okay, so the top is not closed. Okay, it is open to the atmosphere, and the height from the balloon center, okay, if this is approximately the balloon center, okay, uh, from the free surface is h. Okay, so now the first question was, so here there was the first thing due to which my interview gone wrong. Okay, and what was that thing? So he told that okay, you have all over same temperature, uh, 30 degree, 30 degree, 30 degree. Okay. Now he told me that okay, you draw a PV plane. So I drew a PV plane like this. Now he asked me, okay, now you know the initial volume and pressure. So he told me that the initial volume VI is given, and you also know the PI. Okay. So I just asked that, okay, sir, PI will be equal to the ambient PI, right? So then, sir, who was asking me this question, he said, yes, obviously. So then I was like, okay, so if at this point outside the balloon, if the pressure is P and that will be obviously H rho G, then inside the balloon also that will be H rho G. I asked this. Now the chairman rudely asked, wait. You say that what will be the exact value of the pressure inside the balloon? Okay. So this was the first official question. Exact value of pressure inside balloon. Okay. So now see, if you know that if you have studied the, I mean, pressure vessels, or if you have studied the surface tension, then you would know that this pressure inside the balloon, if this is something called P in, then this will not be exactly equal to H rho G. Okay. And why that is so? I can easily actually prove that if I have a small part of this balloon, okay, then if this is the pressure P in and this is the pressure P out, and see there is a tension, right? So maybe I have just this part of the balloon. Okay. So that means if you see that this PO minus P in minus something, if it is something theta, then 2t cos theta, that will be 0. That means PO minus P in is not 0. I can only say that my PO minus P in is 0. I can say this only if my this T is neglected. If I am actually neglecting this T. So I was constantly thinking that I can approximately tell that what will be the pressure inside the balloon, but I cannot exactly tell. So then I thought, okay, I asked them, "Ki, sir, can I assume that the gas inside the balloon is an ideal gas?" Then he told, yes, you can assume. Then I did one thing that, okay, that means my P in will be R P in by V in. And we know this VI is given. VI is actually the V in at the, I mean, initial position. Okay. And T in is given at as actually my 30 degrees Celsius. That means this is actual answer. This is actually correct. Okay. Then the chairman asked me, no, you have to tell it by any other logic, the exact value. So this is actually correct. He told me that, okay, this is correct, but you have to tell us by any other logic. Then I was thinking that, I mean, what can I do? What can I do? What can I do? Then I told, sir, okay, if this surface has to be in equilibrium, then it has to be H rho g. Then the sir who was asking the actual interview question, then he asked me that, will this be always the case that if I have a curved surface, then the pressure inside it and outside it will be equal? Will this be always the case? Then I said, no, sir, this will not be always the case. This will be the case only if I neglect the tension. Now, the chairman made a very harsh comment. This took you 15 minutes to tell that the pressure will be H rho g. So the chairman was actually asking the approximate pressure, neglecting the tension. But I was thinking that he was asking the exact value of the pressure. That is why I was not answering anything other than this. Okay. So at this point, we have to understand that I have always heard that the BARC people are very much cooperative. Yes, there were some people who were actually cooperative, but in my panel, the chairman was not cooperative at all. Okay, he was constantly throwing harsh comments towards me. So then I could have told, ki, sir, I was thinking about the actual pressure. That is why I gave this answer and not H rho g. H rho g is not the actual pressure. I was thinking that he is asking about the exact value, but he was asking the approximate value. But he told me, can you precisely state that what is the value of the pressure inside the balloon? So, I mean, what can I tell about this? And when you get this type of comments in the interview panel during the interview, then you can actually guess that, I mean, what was my mentality at that time. So my confidence level actually dipped down. Okay. Still, I tried to be calm. So then the sir who was actually asking this question, he continued, okay, you have now your PI and VI. VI is given. So VI is any constant and Pi is equal to H rho g. Then he told me that firstly, you tell me that in the string, there will be tension or not. So tension in the string. So this is present or not. So I told very much confidently and actually not confidently. So this was a very easy question, but still I was not very much answering confidently because of that harsh comment. Okay. So that is the thing. I want you to expect all these things. In your panel, the chairman and I mean all the interview board members can be very much good, can be very empathetic and good. Okay. But it can be the case that they are not very much cooperative. So you have to build that confidence that I am saying this, that means this is correct, and you have to prove them by, I mean, logic. Don't actually accept, I mean, anything and everything in front of them. At the most, what will happen? You will not get the job. Okay, but if you cannot express your thinking to them clearly, which I failed to do, then you will surely not get your job. Okay, so tension in the street, present or not? Obviously, yes. Then value of the tension, value of the tension. Okay. So then you need to draw the FBD of the balloon. So if this is the balloon, then this is the tension, this is the weight of the air, and this is the buoyancy force. Then he told me that okay, you can neglect the weight of the air. That means this tension T is equal to the buoyancy force. They look satisfied. Okay. Then they told me that if I now cut the string, okay, if I now cut the string, then what will happen? So I told them, sir, the balloon will rise. Then what will happen? Okay. Then he told me, draw the PV diagram for the gas inside the balloon. Draw the PV diagram for the gas inside the balloon from the initial height, that is h, to the height of the balloon, that is h by 2. Okay, draw the PV diagram for the gas in the balloon for h to h by 2. Okay. So after the string is cut, clear? Okay. So you have to draw the PV diagram. Okay, so then I made the next mistake because of my nervousness. So everything actually gone wrong when I get that comment. He actually further put a comment that this is the, class 10 physics. That is the pressure is the H rho g. So he was thinking that I cannot understand that at an height below the free surface, at an height h, the pressure is H rho g. So he was thinking that I am not understanding that. But honestly, I should say that this is my mistake, that I should have told him that no, sir, I was thinking this, that you are asking the actual pressure and the actual pressure will not be H rho g. Okay. So this is the things that you should learn from my failure story. Okay. So the PV diagram. So now at this time, I was thinking correctly. I was thinking that okay, the balloon will rise and the pressure will actually reduce. Now the volume will increase. So the pressure will reduce and the volume will increase. And then I asked them, sir, is it a very slow process, or is it a very fast process? So then the chairman, again told that yes, the balloon will rise very much quickly, right? Okay, but his tone was not actually very much empathetic or very calm. Okay, his tone was very aggressive during each and every comments. Okay, now, okay, that means if it is a very quick one, I have to take the adiabatic. So I have to take the adiabatic case. That means it will be an adiabatic expansion. Now, I heard that in BARC, you have to take all the assumptions very much carefully. Okay. Now, I thought, okay, it can be adiabatic, and they have told that I can take it as an ideal gas, but still, I should tell that this may or may not be a, reversible process. So I told them, "Ki, sir, so I first draw this curve. Okay. So this is the VI and PI, and this is the V final and P final. Okay. Then I was explaining the right thing, that okay, the balloon will rise, it will expand. Then the volume will increase and the pressure will decrease. Then the teacher who actually asked this question, he told me, but you have done something else. At that time, the interviewer, the chairman, was sipping on the tea. Okay. He was not even listening to me. Okay. So then actually that sir who was asking this question, he was very much polite. Okay. So now I understood my mistake, that the curve will be something like this. Okay. Where this will be my VI and this will be my PI and this will be my PF and this will be my VF. Okay. So then I told that this is an adiabatic expansion. Okay. Then he again told me, can you find this VF from any equation? Then see, I was thinking that they have not told that it is a, reversible one. Then I cannot apply PV to the power gamma equal to constant. Then I was thinking, here and there, that what I can do, what thing I can do, and all these things. Then I was writing that okay, adiabatic means my du is equal to my dw. That means this is equal to pdv. I was writing these things, that okay, that means my integral dy, if I can write it as cvdt, because it is an ideal gas, then I can write it as this. So then I was thinking that okay, sir, by this equation, if I know the final temperatures and the final internal energies, then that sir told me, don't you know any kind of equation for an isentropic process? Then I was like, are you don't mention any isentropic thing. So they did not mention, and they expected that I should assume all these things. Okay. So I will not blame anyone, but you need to learn. Okay, that if you are not, getting any kind of assumption, then you should ask them immediately, sir, is it an isentropic one? Is it irreversible or reversible. Had I asked this particular question that, sir, is this, process irreversible or reversible? So then I could have answered this at the blink of an eye. Okay. So I I know PI, PF and VI. So putting this in this equation, I can know VF. Fine. Then they asked me that, okay, now draw the isothermal expansion. If it was the isothermal expansion for the balloon. So then I drew with a different color that the isothermal expansion will be something like this. Okay. So maybe this is the VF iso and this is VF adia. Okay. So then they asked me that, okay, the final volume is more in case of isothermal, right? So then they asked me that explain. So it is sixth question. Okay. Then they asked me explain why the final volume for isothermal is more than the final volume for adiabatic. Why VF iso is more than VF adia. Okay. And I have to explain it physically, not by any equation. Now, this is the question for which the exact physical reason I cannot answer right now also. I can give you some hand waving arguments, but I don't have any exact physical reason. What do I mean by any exact physical reason? Exact physical reason means something like this, that if I have a box like this and if I have a box like this, the same box, and I am filling water in both of the boxes, if I only know the flow rate, that the flow rate Qy and here the flow rate Qy dash is greater than Qy, then I can only say that, okay, surely to fill up this box, I will take, lesser time. But I was not having any exact reason. So again, if you can find any exact physical reason, not any mathematical reason, we can, easily answer this from the equations PV equal to constant for isothermal and PV to the power gamma equal to constant for adiabatic, but not using these equations. You have to answer by your physical reasoning. Now, I have found an answer. If you are satisfied with that or not, I don't know, but I am not satisfied with that. That is, in isothermal, you are giving some energy from outside, and in adiabatic, you are not giving any energy from outside. That is why, as you are giving any energy from outside, the volume expansion will be more. But again, this is not a very good logic. Why? Because even if you are adding some energy for an isothermal case, but still that energy can have two parts. One, increasing its volume. So what I am trying to say is, if I have the balloon, so for the isothermal case, you are giving some outside energy and your du is 0. That means your dw is dq, and this dq you are supplying from outside. So this dw will be according to that energy. Okay. And this dw is equal to pdv. So all the energy will be spent to expand the balloon. Now, for the same balloon, if you are having an adiabatic expansion, then your dq is 0 and the internal energy is converted to the work done, and that is what is bringing the expansion. Now, how can you argue with me that this dq is more than this du? If you don't know that what is this dq and this du, then how can you argue that just because I am supplying this dq from outside, this dq will be more than this du? If that is the case, then only you can say that my expansion for the isothermal case is greater. So this is an open question. So I have actually found the answer of this question also, a very good answer, but this is your homework. You have to think about it. Okay. Okay. So in the actual interview scenario, I was not able to answer this question. Okay, so this video will be a bit long. Okay, because I want to, elaborate everything. Okay, so now question number 7. So now they went to heat transfer. Okay, then they told me that if I have two tanks, one is circular and another is square like this. Okay, and the height h is same. Okay, height h is same. Okay, and the this area. Okay, this area and this area, these are also same. Okay, so this was the thing. Now you have to tell, is this possible at all? Let me see. Yes, I think it is possible. Okay, that means the volume is also same. So the surface area can actually vary. The question was that if now I have both the tanks, a fluid with 90 degrees Celsius temperature, then you have to tell, then the fluid will be cooled faster in which tank? In tank A or in tank B? Okay. Now at this point, my confidence was, really deep down. Okay. Because I faced so many harsh comments and I failed to answer already a particular question. Okay. So the answer was very simple, that you see the rate of cooling is dependent on the volume by surface area, or the area by volume. More is the volume, more is the tendency to capture the heat, to retain the heat. More is the surface area, more will be the heat transfer rate. So that means more will be the surface area and lesser will be the volume, the faster will be the cooling. So the this will be 1 by T, proportional to 1 by T. So this T is the time of cooling. So you see here the answer is actually very simple, that for any shape, the sphere and the circle will take the least amount of surface area. So for both of these, the volumes are equal, and this surface area for the sphere will be lesser than this surface area for the square shaped tank. So TB will be lesser than TA. But honest, in the interview hall, I took at least 5 to 10 minutes to answer this, because at that time my brain was not working in a good condition because of having a very low confidence at that time. So I was actually calculating VA, okay, sorry, A by AB. And to calculate the A by AB, you need to find the A, right? You need to find the A. So to do that, you need to do one thing, that is you need to equate the volume, that is H into pi r square is equal to, okay, H into B square, right? H into B square, that means B square is equal to pi r square. Now you know the relationship between B and R, then then you can find this A by AB. So I found this A by AB and I showed that this AA is actually less than AB. That is why TB will be less than TA. So I showed them a, a clear mathematical proof. But then the sir who was asking this, then he directly told me that I was expecting a very firm answer and a very quick answer from you. Without using a chalk. Okay, chalk and board. Obviously, I was doing all these things in the chalk and board. And when I said that, okay, A by AB, I got something like this. It is like 1 by pi, something like that. Okay, I can't exactly remember. And I told that this will be less than 1. Now that chairman, he was not at all seeing towards me. He was gossiping with other scientists. And suddenly he saw that I have written this. And he laughed and said, so after this 10 minutes, you got 1 by pi less than 1. This is your, conclusion. Then I was pissed off a bit. I told, no, sir. my conclusion is A is actually less than AB, and that is why TB will be less than TA, I told. So I found after this BRC interview that okay, I need this job, but if I cannot be confident with my answers, then I cannot get any job. So I maintain this mentality in ISRO and in DRDO. If I know something, then I will tell that yes, sir, this is correct because this is the path. In ISRO also, they asked me a tricky question. I will surely upload my interview experience of ISRO also. Okay. So there also they asked me some tricky question and I answered something on which the ISRO scientists were okay. Are you answering the right thing? But I knew that I am answering the right thing and I told with a good confidence in ISRO that I am answering the right thing and I was selected in ISRO. Okay. But I was not selected in BARC. And this was not the mistake of the chairman. This was the mistake of mine, only mine. I am the sole person who is responsible because I was not having that much confidence. So you need to understand that your panel members may not be like mine. They may be very good, but they can be worse than mine. Okay, so you have to build up that confidence. That is very important. And how you can build up that confidence, for that I will make a separate video to share you the interview preparation strategy. So now let me go to the next question. Again, I will see that I was right. So then they told me, okay, now you have to consider the outside wall for the cylinder also. Okay. So if it is the outside wall of the cylinder, then they told me, okay, then this center line is having the temperature at 90 degree and the ambience is having the temperature at 30 degree. Then they told me, okay, you first draw the temperature profile inside the cylinder and the cylinder wall. When I started to draw, okay, now see, if a fluid is having a temperature gradient in horizontal direction, then it will have a density gradient also, until unless it's, I should say, density is not a function of temperature. If that is the case, then the density will be constant. But if it is having a gradient of temperature along the horizontal direction, then you have studied in your natural convection, then this fluid cannot be at static equilibrium. So at the center line, the fluid will rise like this and it will have a circulation like this until unless the temperature is uniform. Okay. So then I was telling them, ki, sir, the fluid will be circulating. Then again the chairman just screamed like, what? I told that it will be a still fluid. But again, I was having in my mind, how can be the fluid still? They did not told me that the fluid is still. Okay. Then the chairman told me, okay, you can explain us that why that will be circulating. So at that time, I was like, नहीं sir, आप जो बोल रहे हैं, आप सही बोल रहे हैं. Okay. So again, I was like, okay, कि मैंने मान लिया कि I am wrong and the fluid is still. But this was the mistake कि मैंने मान लिया. I should have told that no, sir, there will be a horizontal temperature gradient. Because of which there will be the natural circulation. So now, then he told me, draw this. So I made the mistake to draw it as a linear, then I drew it as the logarithmic. So the answer will be that if it is a still fluid, then both of them will be logarithmic but with a different nature because the thermal conductivities are different. But I drew it as linear and this as logarithmic. This was solely because of the dip in my confidence. I made this kind of mistake. Okay, this is a very easy question. Okay, this will be the answer. Then I saw that they were not satisfied and then they told me, okay, can you draw the profile outside that? So then I drew the profile outside that and I drew something like this and this was correct. Okay. And this will be the thermal boundary layer. Okay. This will be the thermal boundary layer. So now they asked me that, okay, now if I put a fan and that will blow air vertically like this, it will blow air like this, then what will be the change in the temperature profile? Okay. And then they were like, rapid firing. I told them, okay, sir, give me some time. So these are very easy questions. I actually love heat transfer, thermodynamics, fluid mechanics. Okay. So what will happen is the boundary layer thickness will actually decrease. So, you can actually intuitively think. So if this is my boundary layer thickness without fan, okay, then my with fan, the boundary layer thickness will be something like this. So the boundary layer thickness will be decreased. Why? Because if you blow air, the heat transfer will be more. That means it will take lesser amount of distance to reach this ambient temperature. And also all these temperatures will be decreased. So if I draw again the temperature profile, then it will be something like this, and again something like this. And the earlier profile will be something like this. Okay. So if I draw it very clearly, so this, and something like this. Okay. And this is your maybe boundary layer after which the temperature is constant. And for the fan case, it will be this, and something like this, where your boundary layer thickness has been actually, reduced. Okay. So this was actually a very easy question, but due to the deep in my confidence, I was not able to answer. Okay. Then they were done with the heat transfer and they were not giving me time. So the chairman asked, you just tell me that what will happen with the boundary layer thickness. I was very scared. I told like this, ki, okay, sir, it will decrease. Then other sir asked, no, you have to draw the temperature profile. I was like, kya karbi yaar? So I was very scared. So then they told me, okay, you, rub off the board. Then I told them, no, sir, I can try. Then the chairman said, okay, Shoma, now we will do SOM, show. So then there was a ma'am who cracked a very bad joke that Soham will do Shom, ha ha ha. So, okay, so I know that these things are a bit disrespectful. Okay. But I am also, human. I also get angry with those things because that was a very unpleasant experience. Okay. So the more I try to be very calm, the more I become very angry with with the persons and the situation. But you have to understand that the thing is that this was my mistake, that I could not tell them that, sir, I am thinking this thing and I am thinking the right thing because this is the logic. I told these things in ISRO and DRDO. Okay. In DRDO also, I was having some bad experience. And here is the video you can see. And in ISRO also, I will share the experience that I was asked very tricky questions where I answered, despite being asked that, are you sure about this? I answered very much confident. Yes, I am sure because this is the logic. Okay. So now the last part is SOM. So in SOM, they asked me first draw a cantilever beam. Okay. And you have a moment here. Okay. Now the sir who was asking me the questions from strength of materials, he was the youngest panelist, and he was actually very good, very humble. So you see, I have seen that when people become aged persons, they become something like, क्या हो जाता है उनको यार, पता नहीं जब मैं भी मतलब बूढ़ा हो जाऊंगा तब ऐसा मतलब तब शायद ऐसा हो जाऊंगा, पता नहीं. So he told me that if you have a cantilever being like that, so then draw the shear force diagram and the bending moment diagram. So this thing I am not drawing. Okay, this is very easy. Okay, I'm just not drawing this. Now the second part, the same person was asking, the same young scientist. Okay, now you draw if you have only a load here. If you have only a load here, the shear force and bending moment. And then after that, you will merge those two diagrams. He instructed me to do this. The chairman was like, no, 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 you say this thing. So they were like कि वो तो बच्चा है मतलब जो मतलब मुझे पूछ रहा था. He was the youngest scientist. So he said, no, 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 you tell me if I now shift this thing here, then what will happen? So actually what will happen, you can clearly see that up till this, the bending moment will be 0. Okay, if I take this part, I mean this loading and not this loading. Okay, then if if I draw the bending moment diagram x with m, then here the bending moment will be constant and up till this the bending moment will be 0. Okay, so the thing is, now you see, sorry, it will be the other way. It will be the other way. जो भी हो, मैं अभी वो draw नहीं कर रहा. It will be the other way. So that will be the thing. Okay, you have to draw. Then they asked me that okay, if I now put the bending moment like this here, okay, at the end, then what will happen? Then I answered that throughout throughout the rod, there will be a constant bending moment. And I think, yes, I answered the right thing, that here here it will be 0 and here it will be a constant bending moment for this loading. Okay, for this loading. But when I have the loading here, then I thought that okay, it will be balanced by this moment will be balanced by this one, then throughout the rod it will be 0. So I first answered that it will be 0. But then I thought ki no, if I take any section, then I can have another moment accompanying this one, okay, to balance this one. That is, if I take any section, then to balance this moment, I will have another moment. That means it will be a constant diagram. It will be a constant bending moment diagram. But now the bending moment will be in the negative side. Okay. Now the bending moment will be in the negative side. Clear? So now they told me, okay. So now they told me that when this negative bending moment will jump up and become this positive bending moment. I answered very firmly that sir, that if we put this bending moment just at this side from the fixed support, then only it will jump. So if I put the bending moment like here, okay, it is just at the right side from the fixed support, then the bending moment diagram will be something like this. So see, I am not teaching you SOM. Okay, I am just saying that what I answered. If you think that these are wrong, okay, so this is the thing actually. This will be the right. If I apply the bending moment just at the right side. Okay. So now they told me, okay, for this case, you tell us that you draw the nature of the slope. You draw the nature of the, deflected curve. So I drew it like this. Then they told me, okay, now you tell me, the sir was asking, that sir, who was asking me the tank question. So then he asked me, you tell us that what will be the shape of this deflected curve? Will it be a circle or a parabola? So then the chairman added, no, you can have any other options, circle, parabola, hyperbola, ellipse, exponential. So he was like कि आज इसको मैं अच्छे से भूनूंगा, grill करूंगा. So then it was a very tricky question. If you go by this equation, that is d2y by dx2 is equal to m by ei, then you will get a parabola. But for a constant bending moment like this, it will always be a circle. And why is that? They did not ask me, but I ask you that although from this equation I am getting the equation of a parabola for a constant bending moment, but why the actual shape is circle? If the actual shape is circle, then this formula is wrong, right? But still we use this in SOM. So why is the case? So I will bring a separate video for this interview logics. Okay, that you need to understand. I have already made a video on SOM and that will be published soon. Okay. But after that, okay, this will be circle. And then they look satisfied. Okay. But I cannot say about the chairman. I mean, he was in a, different mood. Altogether. Okay. So this was all about my interview experience. Then they told me, okay, Soham, your interview is over. You can go. Now you saw that with the first harsh comment, I lost my confidence. And your case, the same chairman can be there, and also in your case, a very good chairman can be there. But at the same time, even if the teacher is good, the interview panelist is good, you will always not tell you that you are speaking wrong. They will help you that, okay, so you are saying this, but how is this? Because if this is the case, so they will give you some chance. Like, when I was not able to find the final volume during the PV diagram for the 10 question, then the sir gave me an hint that don't you know any equation for isentropic? Okay, so like that, they will give you hint. But after that, if you answer it wrongly, then maybe if the person is good, so he will not demean you like the chairman whom I faced, but they will not tell you anything else. They will tell you, okay, okay, fine, fine. Okay. So you have to build first of all your confidence. And how can you build your confidence? If you can build the interview logic. And how to build the interview logic? For that, you have to wait for the next video. So in the next video, I will not only talk about the exam preparation strategy, but also about the interview, which is the hardest part. So in this video, if I put a summary, then what is your key takeaways about the BARC advertisement, and also what is OCES and DGFS program, and also what is the stipend 74,000 per month during your OCES and DGFS program, and what are the gate papers, in which you should apply if you want to be a BARC scientist, and also for that, what should be your BE qualification in which branch. That all these things actually you can find in the document. I will give the link obviously. Other than that, I have also told about my interview experience, and it was really a scary interview experience. So all over, you need to build up that confidence. You need to build up that ability to speak. And I am doing the right thing. Yes, they are scientists. They are big scientists. They are one of the smartest minds in the country. But still, if you think that I am saying something, correct, then you should tell that, whoever it might be a scientist, be a layman, a normal person. If you are right, then you need to have the courage to say that. Not in BRC, but in any interview. Okay, especially in academic interviews. Because see, this was a miscommunication. The chairman was thinking that I was not understanding the H to G, but actually I was understanding the actual thing, that the pressure inside the balloon will not be H to G. Okay, so this was a miscommunication solely because of me, because I did not tell my thing. Okay, you have to express that. And to build up that confidence, you need to build interview logic. So I will meet you in the next video. Until that, you can go through my DRDO experience and my IISc interview experience. So I will meet you in those videos. Until that, goodbye, take care, and thank you. Hey, wait. Sab kuch to ho gaya, yaar. But if you think that after this 1 hour 18 minutes, I have done something for you, if you think that these guys are trying to do something for us, then please subscribe this channel. This will give us motivation. Yes, I want to earn money from this channel, but subscribers don't give us money. The views give us money, but yes, subscribers also matters for the growth of the channel. So, but having said that, I want money, but obviously at the sake of anything that I am doing good for you. Okay, if I am not doing anything good for you, then this money will be like, okay, I mean, वैसे तो पैसा आएगा नहीं क्योंकि तुम लोग देखोगे नहीं अगर मैं कुछ अच्छा नहीं बना रहा, लेकिन जो भी मैं कहना चाहता हूँ कि if you think that I am doing something good, then please subscribe to my channel. Okay, thank you all for the love.